Well, howdy there, Internet students. It's Mr. Hermanson again. So today we're going to study surface area a little bit more and try to figure out if there is like a best size to use. Engineers have to do this when they're creating a box and they need it to fit in a certain space, or they want to use the least amount of material to make that box and have everything fit inside it. Okay? Um, so let's look at three different rectangular prisms and go ahead and find their volume and their surface area. Now to find their volume, you just have to multiply the base area times the height. So in this first prism, I'll do it with you. I'm going to pick the base as just because I think it'll be easier for me. I'm going to pick this end to be the base. So that base area is 1 times 1, which is 1. And then I'm going to use 8 for the height. And so the volume is 8 cubic inches. Okay, and then the surface area, you have to find the area of all the surfaces. Now remember, in a prism there's 6 surfaces, so this black surface right here is 1 by 1, which is 1, but there's another one exactly like that. So we need to do 1 plus 1. This front face here is 1 by 8, so that's 8. That's going to be the same as the back, and it's actually the same as the top and the bottom. Okay, and then I'm going to add all those up. I get a surface area of 34 on that one. All right, go ahead and check out, find the surface area of the and volume of the other ones. All right, so what do you notice about the volumes of these three prisms? You should notice they're all the same. They all have a volume of 8 cubic inches. And the one that has the largest surface area is the first one, the 1 by 1 by 8. The one that has the smallest surface area is the last one, which is a cube. It's 2 by 2 by 2. And why do you think there is a difference in the surface area? Think about that for a moment. Here's the deal, you guys. By stacking these cubes up, you're actually hiding some of the faces. Like if I stack these 4 on top of these 4, I'd be hiding these faces in between. So the more you combine them and put them together, the more faces you're hiding. So you're going to end up with a smaller surface area. All right. So it turns out that the smallest surface area is the most compact version of that same volume. Okay, so so go ahead and just see if you could think of which of these do you think will have the smallest surface area. Give that a shot. Okay, just based on what we saw, you should have picked prism F. It's the most compact. It's the most like a cube. In fact, it is a cube. Okay, go ahead and fill the rest of this out. What are their volumes? How do you find the smallest surface area dimensions? And so on. Answer as many of those questions as you can. All right, so to find the smallest surface area dimensions, you want the most compact version. To find the largest surface area dimensions, you want the most spread out version. One thing to think about on that is you could keep spreading it out if you didn't use integers for the side lengths. You could have like 0.1 by 0.1 by a super long one, so it just keeps getting bigger. So think about this and use your calculator to see if you can help figure that out. Just kind of guess, but remember that you want the most compact, the most like a cube. So if you could think of, and I'll just do x times x times x, if you could come up with a cube that has this volume, and you're going to multiply length times width times height to get that, that would be the smallest surface area. See if you can find that. I don't know if you found it, but 11 times 11 times 11 equals 1,331. So that means those dimensions, 11 by 11 by 11, would give the smallest surface area because that's a perfect cube. Okay, what dimensions would produce a largest surface area? If you had to use integers, you would say 1 by 1 by 1,331. That's, you could spread it out the most by doing that. If you could use decimals, you could even do smaller, like 0.1 times by 0.1 by a really big number. Okay? All right. You can find the surface area from a net. Simply find the area of the different shapes to make the net and adding the areas together. Remember that the surface area is measured in square units. I'm going to take you one step further and notice that these nets are always 3 rectangles. Look at this big long rectangle here. All right, and then you have the 2 other rectangles, and I'm going to call those the bases. All right, so if you want, you could find the area of this one big rectangle, and to do that, you would just find all these numbers, 3, 6, 3, 6, added together times 16. And actually adding 3 and 6 and 3 and 6 is actually the perimeter of the base. Multiply that by 16 and then just add these 2 on. Try that with these 2. I'll show you my work on that. Okay, so if you didn't get that, so watch this blue line here. That blue line equals this dimension here, this 4, this 6, this 4, and this 6, which is the perimeter of this. We'll call that the base. Okay, so find that perimeter. 6 and 4 plus 6 and 4 is 20. Multiply that by this distance here, which is the height of the prism. And then just add the 2 bases, and both bases are 4 by 6. And you got 2 bases, so times 2. So 120 plus 24 times 2 is 48 equals 168. All right? All right, so go ahead and see if you can answer these next few questions. A cube has all the dimensions are the same, so equal dimensions. 3-dimensional shape where the dimensions are equal. All the faces are squares. So the surface area cube with side lengths of 8, you should have thought, well, one of those surfaces will be 8 by 8, which is 64, and there's 6 surfaces. So you're going to multiply that by 6, which is 384. All right? If the side lengths are 4, one of those faces is 4 by 4, which is 16, times 6 equals 96. Okay? Now, if we want to find the side lengths of a cube with a surface area of 216, remember this surface area is adding all 6 faces. So we're going to do 216 divided by 6, which is 36. And then we have to think about what number times itself equals 36. Remember, you can do the square root to get that. So the side lengths would be the square root of 36, which is 6. So we're backtracking there. All right, you try this one. See if you can figure out what the side lengths of that one are. You should have got 5 for that one. All right, so here I'm going to show you my little formula for finding the surface area of any prism. It actually works pretty good here. So the surface area, we'll call that SA for surface area, equals, remember that this makes a big rectangle when we spread it out into a net, and that this length right here is the perimeter of the base. So I'm thinking of this as 3 rectangles, the base rectangles, and then the big the big rectangle that wraps around. So I'm going to take the perimeter of the base, so we'll call that big P for perimeter of the base, plus 2 times the base area. And this can be used on any prism. So the perimeter of the base is, we're going to add the 22 twice and the 12 twice, so that's 44 plus 24 is the perimeter. Oops, I forgot to put the height in there. So that perimeter is 68. We're going to multiply that by the height of the prism, so that's this distance here, times 28. And then we just have to add the area of the two bases. And each base is 22 times 12, which is 264. And we have 2 of those bases. All right. And so we get 68 times 28 plus 2 times 264. So our total is 2,432 square centimeters. All right. Now, if you didn't like that method, you can always just find the area of each of the 6 faces, or the 3 faces that you see, and then double each of those and add them all together. That's the other way you can do it. All right. I think you're ready for your homework. Go ahead and do that, and we'll talk to you soon.